Hello and welcome Maths Mastery Academy. We're going to be looking at another topic today for our pre-course resources series, cutting and reforming circles. Now, I can't wait to dive into this with you. Before we start, I'll just give you, just in case you don't know, a couple of basic rules about finding the area and perimeter of circles, as well as some of the key terminology too. So if we have a circle, there's a few key parts of a circle. Of course, there's the center. So the center is equidistant, so it's of equal distance to any point around the perimeter of the circle. Now, when we have a perimeter of a circle, we call it the circumference. Okay? And any line passing through the center of the circle from and touches each side of the circumference, that is called the diameter. Now, the length from the center of the circle to the circumference, or is half the diameter, and that is called the radius. Now, that's probably all of the key terminology you need for this lesson. I'll just tell you a few more key parts though. If you have part of a circumference, it is called the arc length. If you have a random line that doesn't go through the center of the circle, that is called a chord. And if you have like a pizza slice type piece of the circle, like this one, that is called a sector. Which is different to when we divide the circle with a chord, we divide the circle into segments, specifically a smaller segment and a larger segment. The smaller segment we call the minor segment, and in our case, the whole rest of the circle would be the major segment. Okay? So there's a subtle difference between segment and sector. Sector, so your pizza slice, which is formed between two radii, this radius and this radius, and which meet at the center. Minor segment with a chord that doesn't touch the center point of the circle. Cool. And a couple of facts about circles. So if we know the radius and we want to find the circumference, we can do this, or we can express this as this special value 2 times pi times the radius, which we normally just denote r. Now, what is pi? So if we have a circle of diameter 1 and you measured the circumference of the circle, you would get a number approximately 3.14. So you could do this like with a piece of string. If you set your diameter as maybe like 10 centimeters, you measure the circle with that piece of string, you'd be about 31.4 centimeters. Now, for a circle of any size, you can just do pi times the diameter, or pi times d, or 2 times pi times r, because of course the diameter is twice the radius. Okay, that is literally how pi is defined. It is defined as the number, which is the ratio of a circle's diameter to a circle's circumference. Okay, so the diameter to the circumference will always be in a ratio of 1 to pi. And that is how pi is defined. Now, when considering the area of a full circle, we can calculate this by doing pi times the radius squared. And with that information, you can now dive into the questions that we're about to look at. Now, you might not even need a lot of this information. This is everything you need to know about circles for now, in terms of their perimeter, area, and their key parts. You may even be able to simplify some of these questions down, so you don't even need that information. Now, in the figure shown, each arc is of radius r. What is the perimeter of the figure? Again, I'll give you a moment just to have a think. Maybe if you want to, you can pause the video and give it a try. So you may want to start by labeling that radius r. And then we want to count, okay, well, how many quarter circles, or how many quarters of the circumference of one circle of radius r circumference do we have? So you've got 6 quarter circles. So we'd have 1.5 circle circumferences, again of radius r. So if we were to calculate the circumference of one of those circles, it would be 2 pi r, as we said previously. But we've got 1.5 of them, or 6 quarters. So you'd have to multiply that by 6 quarters. And we've got the radius on either side, which is just the straight line, and that is on the perimeter. So we have to add that too. So when we simplify this first part, we'll get 3 pi r plus 2r. We could potentially factorize out the r, but I think that's okay to leave the answer in that form. So that will be our final answer, 3 pi r plus 2r. Cool. Let's move on to question 2. So the figure shows 2 shapes that fit together exactly. Each shape is formed by 4 semicircles of radius 1. What is the total shaded area? So again, pause the video now if you want to, give this a try. Now, I'm going to introduce a technique here, quite an important technique, a useful one, because we got some weird shapes here. We kind of got like this weird part. It's not going to be the easiest to work out. We've got a very similar one here. And what to do with this bit and this bit as well. Again, they're the same. We could work them all out. We could work out all of the semicircles, and we would get to the right answer. But there's actually a better way here, and it's using a technique called cutting and reforming. So because we've got this weird shape, if we can cut it into smaller pieces and rearrange them into a shape that is much easier to work out the area of, that would be beneficial. So again, just have a think. How are we going to cut up this shape, move the pieces around into a shape that's easier to work out the area of? So you probably recognize you can chop this off and chop this off and move them to these gaps. So we just get rid of that and get rid of that, which makes it a little bit easier. We still got these like weirdy parts here. We still have to work out the area of this semicircle. Unless you notice, you can chop this part off and put it in this gap. Here, which makes it really neat because now we just have a rectangle and we can work out the area of that rectangle relatively simply. So we know each radius of the circle is 1. So the height of the rectangle is 2. We've got 2 semicircles along, or 2 diameters along the base of the circles. That'd be 4 radii. So that would have length 4. So in total, oops, jumping ahead of myself, 2 times 4 would be 8. So the exact shaded area would be 8 units squared. Cool. Question 3. So you should be able to dive into this one now because it uses very similar techniques to the last question. The perimeter of this symmetrical creature is made up from 2 semicircles of radius 4 and 4 semicircles of radius 2. Find the area enclosed by this perimeter. Again, pause now, jump in. You should know or have some ideas about how to go about this. And it is unfortunately going to mean dissecting, cutting up and reforming the, dare I say, rather cute looking creature. So yes, we're going to start by chopping off his feet and moving that to its kind of hips. We're then unfortunately going to have to chop off the head and move it down to where the feet used to be. And now, once we've done that, we get rid of all of these parts. We've got a square, which is pretty neat. At least it looks like a square. But let's double check. So the larger semicircles have radius 4 centimeters. This would be 8. Diameter of 8. The smallest semicircles have a radius of 2 centimeters. So there's 4 radii here. So that would also be 8 centimeters. So in total, the area enclosed by the perimeter of this shape, 8 times 8, 64 centimeters squared. Again, we're just doing that by finding a similar shape with the same area by cutting up pieces, reforming it into a shape where it's easy to work out the area of. And finally, question 4. This one's going to be a little bit trickier. So a circle of radius 18 centimeters is divided into 3 identical regions by the 3 semicircles as shown. What is the length of the perimeter of one of these regions? So again, draw the shape, start trying to dissect it, see if there's an easy way to do it. And I'll start going through it now. So it's actually quite tricky to see, actually, where are those identical three semicircles at first. Notice again, we're finding out the perimeter, not the area of one of these regions. So let's just zoom in a little bit. I'm going to start annotating that diagram. So we can see if we draw the radius of each of those semicircles, we've kind of got we've split a larger circle up into three parts, obviously. But specifically, each of these parts is going to be a third of the circle. Now we're trying to find the perimeter of one of these parts. So we're going to need to work out, firstly, the perimeter of half one of the circumference of one of the smaller circles. So let's just do that first. That's kind of a straightforward thing to do first. So the radius is 18 centimeters. So the circumference of just this part, so the arc length of the semicircle, I'll just be super specific, arc length of smaller semicircle is, so it's normally 2 pi r. We're going to have to divide that by 2 because it's a semicircle. So it's just going to be pi times r, or 18 pi. And that's the part that I'm now going to highlight green. Now, we also have this part here, which is going to form part of the perimeter. And of course, because they're all identical, that's going to have the same arc length. So we've got 2 of these form part of the perimeter. And then we've also got this part of our larger circle. Now, we know the radius of this larger circle isn't going to be 18. From the center to the circumference, it's going to be the diameter of one of those smaller circles will be the radius of the larger circle. So it's going to have a radius of 36 centimeters. And we're trying to find the purple part. So that arc length, that part of the circumference. Now, because we've split it into 3 equal parts, we know that's going to be a third of the overall circumference. So if we just work out the overall circumference divided by 3, that will give us the length of the purple part. Add it to 18 pi for this green part. Add it to another 18 pi for this green part, and we'll have our final answer. So let's just compute those steps now. Let's just call this the arc length, the larger circle. So it's a third of the circumference, which is 2 times pi, and we said the radius is 36. So, of course, 2 times 36 is 72, divided by 3. Or, if you're feeling very clever,